While vacationing in the mountains, you do some hiking. In the morning, your displacement is 2,000 meters east plus 3,000 meters north plus 200 meters vertical. Continuing on after lunch, your displacement is 1,500 meters west plus 2,000 meters north minus 300 meters vertical. Part A. At the end of the hike, how much higher or lower are you compared to your starting point? So the first thing to take note of in this problem is the fact that in order to solve it, it's going to be beneficial to define our coordinate system. Defining a coordinate system is arbitrary, but there are ways that you can do it to make it most simple for yourself, and you'll see how I do that for Part A. So Part A is just dealing with the vertical displacement, so it's just that 200 meters vertical in the morning and the 300 meters vertical in the afternoon. So you can see on the left, I've defined up as positive and down as negative. 0 is the origin. So you can see the hiker went up 200 in the morning and then down 300 in the afternoon, which you can see both on the sketch and numerically comes out as negative 100 meters, which indicates that the hiker is 100 meters lower at the end of the hike than when he started. Just keeping in mind, displacement isn't the total distance traveled, it's just from that origin point to the final point. So yeah, negative 100 meters from that origin. Okay, Part B, what is the magnitude of your net displacement for the day? So this part has a few more steps than the previous part. We're gonna have to take into account all of the information we've been given in order to first solve for the vector that correlates with the cardinal directions we've been given, the cardinal directions and displacement we've been given, and then utilize the Pythagorean theorem in order to use the vertical vector that we found from the previous problem in order to solve for that total displacement. So you can see on the right, I've drawn out the cardinal directions onto a plane to make it easier, or onto a coordinate system to make it easier, where east and north are positive and west and south are negative. So you can see that the person went 2,000 meters east, then they went 3,000 meters north, then they went 1,500 meters west, and then 2,000 meters north. So you can see I've labeled that point, that final point on the graph, it's 500 meters, comma 5,000 meters, which is, you can see numerically is actually just 500 meters east and then 5,000 meters north when you subtract those figures. And so for this part, we also have to use the Pythagorean theorem because the 500 correlates with the component in the x direction and 5,000 in the y direction, so you can use the Pythagorean theorem to solve for that hypotenuse that would go from the origin up to that final part to solve for displacement for that section of the hiker's distance traveled. So once you use the Pythagorean theorem to do that, you plug in those numbers, you come out with 5,024.93 meters northeast. So now we have that vector for the northeast part, and we are now going to use the Pythagorean theorem again, as I stated earlier, but with that 100 meters that we solved for in Part A, in order to solve for that net displacement. So yeah, you can see that I drew the triangle one more time to kind of show the conceptually why the Pythagorean theorem will work for this. And then you can see you plug in the numbers and you get about 5,025 meters net displacement, which is about 5 kilometers net displacement. So just keeping in mind that the net displacement isn't the total distance traveled, it is the point from where the hiker started to where the hiker ended. So finding the total distance traveled would be different calculations, but this is just net displacement from the origin to the final part. So that's it. Thank you for listening.